Okay, welcome. It's Wednesday, middle of the week. Today, so yesterday I finished going over all the questions. For example, for assignment 2, there were a lot of them, a lot of probability questions. And I actually ran out of time, but I did record the solutions for the last page of questions, and I posted them on the blog. So you can take a look at them later on if you need. Today we are going to start lesson 3. Let's see who's with us today. Is that you, Cynthia? Just wondering who's there, or is it Tiana or Tim? Let's take a look now. Expected value. We're getting into a little more math. We have to do a little bit of math formula work for this lesson, but it's really not that difficult. So let's just read the definition of expected value. Expected value is, or refers to, any game or situation where you're gambling or investing an amount of money, or actually you're investing like in a business opportunity, perhaps like starting a new business or launching a new product. But it's when you're investing some money for a chance at winning more money, and that's what's called expected value. So you should know what that means. And it just means when you're entering into something, an arrangement or a business transaction that involves money, the potential for winning or losing your investment, or perhaps making more money on your investment. The expected value of a situation is the average amount of money you can expect to win each time you play the game or encounter the same situation. There's a formula that can help us with this. So this is the formula. And this would go on your formula sheet with like a little bit of definitions on how to use it. Now what this means, EV obviously stands for the expected value. The E is expected, and so this stands for the expected value. This is the probability of winning, and you should recognize that from, we've been using those symbols for the last few days now in probability. Capital P stands for probability. Whatever's in the brackets is refers to the numerical probability of that event happening. So the probability of winning times the amount of money won, subtract the cost to play. Okay, and this is in dollars as well. So please note 2 things related to this formula. And remember, like, we're talking about value, so this is always related to money. These questions will always involve money. Please note 2 things. The formula is not included on the formula sheet. We don't really have to worry about that this year. You can add parts to the formula if there are multiple win conditions. So this is important. If there's a situation where there's multiple wins, we're going to add more to the formula, meaning sometimes there's just not one way to win in a contest. There might be, 2 or 3 prizes in the contest. So this might be expanded. There might be 2 or 3 of these. But let's get started. A game is played where a 6-sided die is rolled. So that's our standard little die, like the die that you use to play a board game. The cost to play the game is $5. If a 1 is rolled, like the side with 1 shows up, the player wins $25. If anything other than 1 is rolled, the player loses the $5 bet. All right, so calculate the expected value of this game. Now the formula is here, but I'm going to write it right here as well. So expected value equals probability of, okay, so how do I win this game? I'm just going to personalize this formula to what I'm looking for. If a 1 is rolled, the player wins. Okay, so the probability of rolling a 1, right? That's how I win this game. The probability of rolling a 1 times the amount won minus the cost. Okay, so I'm just personalizing it a little bit there. So my expected value is going to be equal to, so what's the probability of rolling a 1? Well, there's only one side with 1 on it. So that's going to be 1 out of 6 because there's 6 sides to the die in total. It's a cube, 6 sides. Now, how much money do I win? Okay, the player will win $25. Okay, so that's my dollar amount. And how much does it cost to play? $5. Okay. So expected value equals, so I'm going to pick my calculator up, 1 divided by 6 times 25, subtract 5, and 1 divided 6 times $25, subtract 5, and I get, whoops, I'm going to show you my doing because I keep punching the wrong thing in. Okay, so 1 divides 6, hopefully you can see that, times $25, that's how much they could potentially win, subtract $5, and we get negative 0.83. And this is in dollars, right? This is the expected value. So if I get a negative answer, what is the meaning of the expected value? I can expect to lose 83 cents each time I play the game. Okay, so if you get a negative answer, that means you're going to lose money, unfortunately. How much money could you expect to win or lose if you played the game 100 times? Well, if I'm going to lose 83 cents each time I play the game, so I would take my 83 cents times 100, and I would lose $83 each time, or sorry, if I played the game 100 times. I'm probably going to run out of my white tape again, I've noticed. I use it just about every class. If I played the game 100 times. All right, so that's it. So not too difficult, right? You just have to have your your formula out, and you just keep calling or following the same formula each time. All right, let's look over at the next example. That one wasn't too challenging, right? Example 2, let's see what example 2 looks like. A school is looking to have a fundraising activity at their school opening barbecue in September. They are going to have a spinner that is split into 10 equal sections. 2 of the sections say win, and the other 8 sections say lose. A person can spin the spinner for $2. If the spinner lands on a win, the person wins 15. Calculate expected value. Okay. So once again, expected value equals the probability of winning times the money won minus the cost. All right, so let's see what happens. So a spinner, once again, is one of those, it's usually circular. And this one is into 10 equal sections. I don't know if I can do that. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, I think I got the 10. Okay, make that a little. Okay, so mine don't look even, do they? right? So I have 10 sections of my spinner. 2 of the sections say win. Okay, so win-win. And the other 8 say lose. So I'd have a lose, 1, 2, 3, 4, 5, 6, 7, and I think I missed one here, 8. Okay, so 1, 2, 3, 4, 5, 6, 7, 8 chances to lose and 2 to win. All right, probably didn't need my picture, but I just wanted to refresh your memory what a spinner was. So the spinner is supposed to be all equal segments. So when you spin, there's an equal chance to land on any one of the wedges. So if the spinner lands on win, the person wins 15. So the probability of landing on win would be equal to 2 out of the 10 sections. Okay, so that's my probability of winning. That's the important part for expected value. I think that's the toughest part. So expected value equals 2 out of 10 times, all right, they win $15, but it cost them $2 to spin. Right? So once again, and remember 2 over 10 is just 2 divided by 10. And you can just punch all that into your calculator. So let's see if you can see my calculator. 2 divided by 10 times 15, subtract 2. And I get 1. So expected value is $1. Do you think that this game is going to help the school raise money? Explain your answer making reference to expected value. Well, since a person playing the game is expected to win $1. Okay, now not to say it's going to happen for sure, right? That's what probability is about, but those are the chances we're taking, right? Since a person playing the game is expected to win $1, the school would not make money. They would lose money. Because it's expected that people playing the game are going to win. So that's not a great game for the school to organize and play. All right, let me know if you have any questions at all. Move on to example 3. You just bought a raffle ticket for $10. Any individual ticket has a 0.1% chance of winning a trip worth $8,000. A ticket also has a 5% chance of winning a $35 grocery card. Okay, so there's 2 chances to win, right? This is one of those things that they reference. So I can win a trip and I can win I could win a grocery store card. Okay, calculate the expected value of one ticket in this raffle. All right, so let's see. So expected value equals the probability of winning, but we have 2 chances to win. Note, we have 2 ways to win in this raffle. 2 probabilities of winning. So normally our expected value just looks like, normally expected value just has 1 way to win, but this one has 2 ways to win. Okay, so the other thing is 0.1%. This is not a fraction, right? This is not really I know we can express probability as a percent, but using it in our expected value formula, we don't use percents in formulas, so I have to convert that to, so the probability of winning, this probability of winning would be equal, I'd take whatever number this is, 0.1, and that's a number out of 100. That's the actual formula number to use for probability of winning because we don't use percents. And this probability of winning, there's two ways to win, right? Would be 5 out of 100 or 0.05. All right, so the expected value of this game is going to be equal to this probability of winning, 0.1 out of 100. Just like I did this one, 2 out of 10, this one is 0.1 out of 100 times $8,000. Okay, this is my first way to win. I'm going to maybe bracket that off. And I also have another way to win. So and means I'm going to add this second way of winning. So the second way to win is 5 out of 100. A 5% chance is 5 out of 100 times $35. Now the cost to play this game was just $10. So you have to represent your two ways to win if you have two ways to win. Right? This is the winning the trip. You could win the trip or you can win the grocery card. You can see there's a higher chance of winning the grocery card, right? You have 5 out of 100 chances. Here you have less than 1 out of 100 chances, like 0.1 out of 100. That's really low. That's because the trip is more valuable, right? So there's a smaller chance of winning the more valuable prize. All right, so this is a tougher one to type into your calculator, but it's the same way we always do. Now you can use brackets if you want. I used brackets, so I'll use brackets in my calculator. So bracket 0.1 divided by 100 times 8,000, close my bracket, plus bracket 5 divided by 100 times 35, close bracket, minus $10. That's your cost. And I get a negative 0.25. All right, so my expected value equals negative $0.25. All right, $0.25, that's just a quarter, right? That's 25 cents. What is the expected value if you, so this is not, you're gonna actually lose money if you bought a ticket, or there's a greater chance you're gonna lose money when you buy this raffle ticket, which is pretty typical of all raffles, right? But normally we buy raffle tickets to support an organization or community. So we're not that concerned about losing money. I think typically when we buy raffles for charity, we almost regard it like a donation. Okay, what is the expected value if I buy 7? All right, if I buy 7, I take my negative 25 cents and I multiply by 7. And that's going to give me negative 1.75. So I can expect to lose $1.75 if I buy 7 tickets. So this is the chance for every ticket, right? Like no one has a magic ticket. If I bought a ticket for this raffle, my expected value is losing a quarter. If you bought a ticket for this raffle, your expected value is that you're going to lose a quarter. So it doesn't matter who buys the ticket, right? That's just how it is. All right, let's flip over to example. I may as well finish these examples. I'm going to give you work time tomorrow. So let's try example 4. Expected value analysis can apply to any situation where there's a potential monetary gain or loss. All right, like buying a ticket, playing a game, gambling, starting a new business. Anytime you think you're going to gain or lose money. And therefore, business is a common field where this kind of analysis is regularly performed. So let's look at this in a business context. It costs $1,000 for Sherry's construction company to bid on a construction project due to the time involved in preparing the bid. If Sherry submits a bid on a project, there's a 1 in 4 chance that she will be awarded or win the contract. If she is awarded the contract, she will be paid $3,000 for the work. Calculate the expected value of the situation. All right, so here's the cost, right? This is the cost. It costs $1,000. 1 in 4, that's the chance that she wins, right? Probability that she wins. And then that she's paid $3,000, right? This is the amount won. We use that word won, or I guess in expected value, it's the amount of money gained, right? So she would gain 3,000 if she tried this business venture out. So probability of winning would be 1 in 4, right? That's my probability of winning, times the amount won is 3,000. And the cost is 1,000. So these things seem like it's pretty high stakes, right? This isn't a small raffle that you're just supporting. This is a business venture. So this is what actually people do when they start new businesses. And this is what bankers do when you go in and ask for loans for new businesses and things like that. They crunch the numbers. So let's try this. 1 divide 4 times 3,000. Subtract 1,000. Let's see if she's going to be not good, negative 250. Negative $250. So justify whether she should continue to bid on the contracts of this type based on expected value. Now, if we just have to base this on expected value, if I'm just going by numbers, based on expected value, which is a loss of $250, she should not continue to bid on the contract. Okay. Now, there might be other reasons why she wants to bid on the contract, right? Maybe there's other reasons. She's prepared to lose some money at the beginning. But if you just had to base it on expected value, we would say no, not continue. All right. Let's take a look at this last example. Aiko is a traveling salesperson. She drives all around the city every week selling high-end home theater equipment. Her car costs her $260 each week for gas, insurance, and lease payment. Each week, there's an 8% chance of her making a sale. Her commission on the sale is worth $3,250. Should Aiko continue selling high-end home theater equipment in this way? Justify your answer, making reference to expected value. All right, let's look at the situation again. Here are her costs. That's her cost. Each week, the 8% chance of making a sale, right? If she makes a sale, she makes money. And her commission is this much. This is the amount won, right? Amount won, it's her pay. Commission is another word for pay. That's how much she gets paid for. That's her gain, her amount she'd win. 8% chance. We know that we don't use the percents in our formula, so 8% would be probability of winning or gaining the commission is 8 out of 10. Always convert percents to, 8 out of 100. Always convert your percents to the actual probability number that you're going to use in the formula. Should she continue selling high-end home equipment? Let's see. So the probability of winning is 8%. That's 8 out of 100. She will win or gain $3,250 in money. But this actually costs her $260, right? These are both weeklies. She has to pay $260 a week for expenses, but she has an opportunity to make $3,250 a week in money. But she has an 8 in 100 chance of actually making sales. So let's see, once again, in your calculators, 8 divided by 100 times 32.50, and you have to subtract out the cost. Oh, and we get $0. We refer to this as a break even. We refer to $0 as a break even situation. Justify your answer. Should she continue? This means she neither gains or loses money. Okay, this means it's expected anyway that she doesn't lose money, but doesn't gain money. So what should she do? At this point, you can kind of go either way, I suppose. I probably would say something like, I would advise her to continue to sell and try to build her business. Okay. She's not going to be losing money in the short term, it doesn't seem like. So if she keeps going out there and making a better name for herself, maybe she could actually increase her sales. So I think that's what I would advise. Now, keep in mind, if it was a negative situation, I wouldn't advise her to continue on. But since she's breaking even, I think you could actually go either way on this one. And if she's breaking even, you could say, no, it's not worth it. She should get into a new line of business. You could say that if you had some justification. But at a break even, she could kind of go either way. But that's an interesting word to file away, or interesting phrase. That's what break even means. You're neither losing or gaining money. So that's it. I'm going to give you time. We've got a half hour left in class. I'm going to give you time to start working. So how about work on assignment 3? I'll just stay online. And if you have any questions at all, let me know. Pop in, right? I don't have to start my next class till 1 o'clock. So start assignment 3, and I will talk to you. I'm just going to flip my microphone off, but just pop in on live chat or email me if you have any questions about assignment 3.